Kia ora, year 11 and 12. This video is going to give you tons and tons of practice with CUBICS. So lots of you have probably done this little worksheet in class, but I thought it was probably worth making a video of it because it goes over a whole lot of basic stuff. How to find the equation, how to find the center of rotation, and the domain and range for each one. So let's have a wee look. Okay, so what we're going to have on each slide is just a picture of a cubic. And we're starting off with a really basic one. What do you have to do to find the equation? Well, the first thing you want to do is you're going to look for some points. And they're going to help you get the equation. The domain here goes from -2 to 2. So it's -2 is less than or equal to x is less than or equal to 2. Okay, so the graph doesn't just go all the way off. It's not just x is all real numbers. Let's just tidy that up. There we go. And the range here is from -8 up to 8, which we write like that. So where's the center of rotation? Well, this cubic is written in, well, it has got a center of rotation here. So I can see that if I spin this around, it will map back onto itself as long as I pick that to be the center. So the center of rotation here is 0, 0. Now the equation of the curve is the most basic form of cubic that there is. So let's look at what we've got. How do I know what pattern it is? Well, cubics come in several forms. If I've got one like this, that's got 3 x-intercepts, it's going to be in this form. Y is equal to a times x something times x plus or minus something, and so on, right? If it's got a bounce like this here, suppose that actually touches the axis, right? Then the form is this: y is equal to a times, let's call this number a here, so no, let's call it b, x plus b, and if this is at c, this is going to be x minus c squared. Okay, so for example, let's put some numbers in. Suppose this number here is -3 and this number here is 2. That would be y is equal to a times x plus 3, x minus 2 squared. So the bouncing here tells me that I've got a repeated factor here. And the ordinary crossing here tells me that I've just got a factor here. Right, and the last one that we've got here is where I've got 3 repeated roots. So the basic form of that is y is equal to some scale factor times x cubed. And that's what this picture here looks like. All I have to do now is work out what that scale factor is. Right, so I'm going pretty slowly on this one, but I'll go a bit faster on the next 8 or so. So what point am I going to use here? Well, I have to use a blobby point. And the point that I'm going to use is 2, 8. So we've got 8 is equal to a times 2 cubed. 8 is equal to 8a, which tells me, it's getting rid of all of this, that a must equal 1. So this is the most basic form of a cubic, right? So a is 1, y is equal to x cubed. So there we go. Now they're going to get a bit trickier from here. This next one has the same shape, but it's been shifted out 1 unit. So the center of rotation is now at 1, 0. The domain is now from x between -1 and 3, but the range hasn't changed. It's between -8 and 8. So the equation of the curve is going to be y is equal to some scale factor times x minus 1 cubed. And I'm going to substitute in the point 3, 8 to find a. So 8 is equal to a times 3 minus 1 cubed. And that again gives me 8 is 8a, a is 1. So my equation hasn't got a vertical scale factor. Right, the equation is y equals x minus 1 cubed. In the next one, we've got a different kind of shift going on. The center of rotation's here. And if you look at it, it's been shifted down 2 units. So the center of rotation is now at 0, -2. And I can see that I've got the same range that I had, or size of range that I had in the first video. So the equation of the curve, some of you can probably spot, is going to be y is equal to x cubed minus 2, right? So it's got this vertical shift downwards, and this is my general pattern. So if I wanted to shift, I don't know, k units down, I'd have y equals x cubed minus k. So the domain here is from -2 up to 2, and the range is from -10 up to 6. Now, because I don't want this video to get really long, I'm going to start skipping some of the domains and ranges because they're pretty easy and they're the same thing. I'm going to keep doing the center of rotation though, because it links in usefully to the graph. So on to the next one. Here we can see that the basic shape is the same, but instead of going from -8 to 8, it's going from -10 to 10. So that tells me a few things. The center of rotation is at 0, 0. So the form of the curve is going to be y equals ax cubed, but this time a won't be 1. So I'm going to sub in 2, 10. We get 10 is equal to a times 2 cubed. 10 is equal to 8a. A is equal to 1.25. So my equation is y equals 1.25 or 5 over 4 x cubed. Next one, I'm still with this basic form of this thing here, or I could have this thing here for y equals -x cubed. Right, so here what's happened? Well, I've been shifted out 2 units, so my center of rotation is now 2, 0. The equation of the curve is going to be something like this. Y is equal to a times x minus 2 cubed, because I've gone out this way. And I don't have any vertical shift. So that's all I've got to deal with. We're going to sub in this point, 12.8 and 4. So 12.8 is equal to a times 4 minus 2 cubed. 12.8 is equal to 8a, giving me a equals 1.6. So you've got two things going on here. You've got a vertical stretch factor, and you've got a horizontal shift in the positive direction. So they're going to get a little bit more involved now. We've got 5 left to go. Right, this one has obviously got a vertical shift upwards. So where's my center of rotation? Well, it's sitting here. It's at 2, 3. The curve is going to have the following form. Y is equal to some scale factor times x minus 2 cubed, because it's shifted out this way, plus 3, because it's shifted up here. And I'm going to sub in 411. I get 11 is equal to a times 4 minus 2 cubed plus 3. That gives me 8 is equal to 8a, so a is equal to 1. In other words, there's no vertical stretch. So y is equal to x minus 2 cubed plus 3. Right, so notice one more time, I've got a horizontal shift that way, and I've got a vertical shift that way. Right, next one. Let's see. Center of rotation is here, and it's been, so the center of rotation is at -2, 1. That helps me with the equation form. Y is equal to a times x plus 2 cubed plus 1. Right, it's plus 2 because I've shifted that way. And now we're going to find a point. Well, the point here that I'm going to use is, what have I got? -1 and 4.9. So 4.9 is equal to a times -1 plus 2 cubed plus 1. So that's nice and easy. We get 4.9 is equal to a times 1 cubed plus 1. 3.9 is equal to a. We have to put it back in the equation though. I get y is equal to 3.9 times x plus 2 cubed plus 1. So let's take another look at this one. How did I do it so easily? Well, I found a centre of rotation here, and I could see that it had this horizontal shift, right? So that's telling me to go and write that bit. And I could see that it had a vertical shift of plus 1. And the last thing that I'm going to find is that scale factor. Now we've got 3 more that look quite different. So here's the first one. This is a cubic, and you can see that I've got some nice blobby points here. 1, 2, 3. I'm not going to worry about the centre of rotation here, or the domain or range, because I'm running out of time. But let's look at the equation of the curve. It's going to be y is equal to a times x plus 2, x minus 2, x minus 3. Now I have to find another point to sub in here. The easiest one to find, I'd like to find a blobby one, but if I can't, I'm going to estimate. So I could use this one. I could use this one, but I'm going to use 0, 12. And that gives me this. 12 is equal to a times 0 plus 2, 0 minus 2, and 0 minus 3. So 12 is equal to, what do we got? 12a. That's nice. A is 1. So the equation of that curve is a pretty straightforward x plus 2, x minus 2, x minus 3. Right, so we've got 3 factors here, or 3 roots here, 3, 2, and negative 2. And you can get them off the graph, okay, because they're sitting exactly on the axis. But what happens here? Well, I can see that I've got a cubic from the shape, but I haven't got any nice blobby points on the axis. So I'm instead going to have a look for whether there's been a vertical shift. So it's kind of hard to do, except that I can see some points here. I've got a blobby point here, and another one here, and another one here. So that makes me really happy, because if I shifted those back down, they would be my x-intercepts. Right, so they're all sitting on a line. That means that I can write the equation like this. I can think of what it was before I shifted it up. So these are the values here where I've got the x-intercepts, right? So I can go a times x plus 7, x plus 4, x minus 3, shifted up by 5. And now I'm going to substitute a point, and I'm going to use a nice easy point. Now, if I haven't got a blobby point, I am just going to estimate, right? But here I can use negative 8 and 3. So I get 3 is equal to a times negative 8 plus 7, negative 8 plus 4, negative 8 minus 3, plus 5. Right, so very quickly doing this, what do I get? I get 3 equals a times negative 1 times negative 4 times, what is that, a minus sign, negative 11 plus 5. It would be good if I'd worked that out. Let's see. So that gives me 3. So negative 2 is equal to negative 44a, which gives me a is equal to 1 over 22. So I've got a very stretchy kind of spread out cubic. My equation is this: y is equal to 1 over 22 times this plus this plus 5. Now it's fine to get that as a decimal approximation as long as you go for quite a few decimal places. I'm rushing now because I want to do this last one. Okay, so what have I got here? Well, it looks like maybe I've got a bounce thing going on. Let's look for the points again. I've got a point here, got another blobby point here, and I've got a point up here which looks like it's not quite at 5. So what I'm going to do is I'm going to use these here, and I can see that this one is a bounce, right? So if I shifted this back down, let's take this off. If I shifted that back down here, what would it be like? So I've got a vertical shift up of 3. Y is equal to a times x plus 4 squared, x minus 1 plus 3, and a works out to be 1 over 18. Right, so I've run out of time. If you can't see how to get that, the point that I'm using here to get the 1/18 is that. Thanks for watching. That's all for tonight.